Good afternoon, class. Today we're going to look at solving quadratic equations. We've already seen quadratic equations in the last homework assignment when we were factoring. I need to do a little writing first. I want to remind you all.
Look back and let them see what we were doing
the last time we were factoring, and we defined a quadratic equation as any equation that can be written in the form ax squared plus bx plus c equals 0. I said a, b, and c have to be real numbers, but a itself can't be 0. And I prefer a to be positive. And if it isn't positive, I'm going to change it so that it is positive.
We'll show them how
you'll see how I'm doing that today. But we said to solve an equation by factoring, we had to make sure it was in this form here. The descending order trinomial equals 0. We factor the expression, and then we set each factor equal to 0 and solve. And I recall doing this problem here, factoring it, and then setting the factors equal to 0, and getting our solutions for the variable. We did several of those, and I think we'll start with number 3. Well, first of all, before we even do that, switch to my paper. I need to write something. A quadratic equation, I said that that's any equation that can be written in the form ax squared plus bx plus c equals 0. And I said that I want a to be positive. We're looking at 3 methods of solving these equations today. There's a fourth method, completing the square, but we're going to see that when we get to circles. It works, completing the square I think works better with circles than here with quadratic equations. So I'm going to say we're going to look at 3 methods of solving. And I think I'll Roman numeral these. The first one is factoring using that 0 factor property, which says get it factored and then set each factor equal to 0.
Previous assignment.
Okay, you're right. I'll say previous assignment. Okay. And we're going to start looking at number 3. Number 3 is an equation that's already in factored form.
What the heck?
What is that? It's let's see. No, that's not it. Oh, okay.
Sometimes it does strange stuff. Okay. Hey, why don't you come up here and pause it?
Okay, look at this equation here. It says just solve. Just so we want to solve for the variable. When you look there, it's in fact, they factored it for us already. It's already in the desired form that we need. Factored form equals 0. It's already written in that form. The problem is that we factor it, set each factor equal to 0, but the problem is that really this is not proper factoring. Look inside that second set of parentheses. 2a minus 6. Is that okay? No, you can't have a common factor. But since we're not entering in a factored form, the way MyLab just generates those numbers, they stuck 2 even numbers in there. If you were factoring something and you typed in those factors, MyLab would count it wrong. Just so you know, you cannot have a common factor inside a set of parentheses. But the important thing is here, they're trying to show that once it's factored, if it's already in factored form, then it's easy to solve. Okay, so let me make sure 7a plus 2a minus. Yes, okay, switch over. So the important thing is they're trying to show if it's already written as a product, set equal to 0, then just set each factor equal to 0. Set 7a plus 5 equal to 0. Set 2a minus 6 equal to 0. Solving this first equation, what will I do? Move the 5 over, that's going to give me a 7a. That plus 5 is going to become what? Okay, a negative 5. And then 7 times a, what do we do to get rid of that 7 in front of the a? Divide by 7 to give us a equals negative 5/7. There's my first answer that I'm going to have to type in. Now the next one, 2a minus 6 equals 0. What will I do first? Add 6 to give me 2a equals just a 6, and then divide by 2. Now we recall doing this at the end of class last time. 6 divided by 2 is 3. So there's my second answer. If the equation's already written as a product, if it's already in the form, factored form equals 0, then great. Set the factors equal to 0 and solve. But you need it. Factored form.
And factored form has the 2 parentheses.
Equals 0. That's what you need.
Oops, let me punch
You better
that
go punch in those answers before we're timed out.
Negative 5/7, comma 3.
Is that okay what he just did? No, that do not put a comma in the denominator. Don't put that 3 in the denominator.
I think it's not going to have any idea what I did wrong there. Okay, so.
It doesn't know that you've messed up entering it.
Okay, so I'm going to come over here.
Remember, once you type that fraction, before you type that comma, do a right arrow on your keyboard or click with your mouse, do whatever you have to, so that that flashing cursor is no longer in the denominator. There's what you wanted to enter.
At first, they'll take some of the problems, it'll count it right if you put that comma down there in the denominator, but then all of a sudden, it's going to stop counting it right and mark it wrong every time without telling you why it's wrong.
So just never put a comma in a denominator, and you'll be okay.
Now let's go back to number 2.
Okay, I bet that one's not already factored.
Yeah, okay.
It isn't. We're going to have to factor this one. Let me write it down. 5x squared minus 6x minus 11 is equal to 0. I remember the last time when we were looking, 5x squared minus 6x minus 11 equals 0. And the last time, here was one. It was written in the wrong order. Remember, you need descending order on one side, 0 on the other. But this one, it's already in that desired form, so we don't have to move terms around at least. Let's see. We need factors of 5. Well, that's nice. 1 times 5, that's it. Oh, actually, this is nicer than I thought. Look at 11. That's a prime number, 1 times 11. So this shouldn't be too hard.
Do you remember, what do we know about the signs?
The last sign's a minus, so how do you get a negative product? Can a positive times a positive give you a negative?
No.
Can a negative times a negative give you a negative?
No.
What has to be true about the signs? There's one positive, there's one negative, and we'll fill that in later. I'll just make a note. We're going to need a plus in one of the parentheses, a minus in the other. Now for 5x squared, 1x and 5x. It's the only possibility. Now for 11, I can already tell we can't put the 11 here. Because 11, when you're finding the inner product, if you put the 11 there, 11 times 5, that's 55. Well, you'd be subtracting another x, but 55 minus 1, that's not going to give you that 6.
You're making it work.
I'm making it work. I think we're going to have to put the 1 here and the 11 there. Do y'all follow my logic why 11 can't go here? When you're finding that inner product, 11 times 5x, that's 55x. That's way far off from what you need. You would still have another 1x, but it would never get down to a 6x. So let's check our outer product and our inner product. So the outer product, x times 11, that's an 11x. The inner product, 1 times 5x, that's a 5x. And do you remember that strange little table that my brother made the last time? As soon as we were starting this, here it is. If that second sign's a minus, you have 1 plus and 1 minus. You wait to fill in the signs until you subtract the outer and inner. You have to subtract the outer and inner to get the middle. Can you subtract these numbers in a way to get 6?
Yes.
Yes. 11 minus 5 gives us 6. But we need a negative 6. So which one of these needs to be negative? The 5x or the 11x? So that when we combine them, we get a negative 6x. I heard someone say it.
11x.
Okay, that needs to be negative, and this one needs to be positive. So to get a negative 11x, we better have the minus there and the plus there. Did y'all follow my logic?
There's a lot of thought going on in here to decide on how to factor those things.
Set each factor equal to 0 then. X plus 1 equals 0. 5x minus 11 equals 0. Oh, this one's nice. It's a one-step equation. X equals, what am I going to get? Negative 1. You subtract 1 from both sides. So there's one of my answers. Now this one. What will I do first? Add the 11. So I have 5x on the left. What am I going to have on the right? I couldn't hear you. Positive 11, I agree. And then divide by 5 to give us x equals 11 over 5. Now, when I say I can't hear you, that just means I can't hear you, okay? Loud music at a young age, yeah. I figure of all your senses, your hearing, yeah. I'm okay with losing that somewhat. Somewhat. I wouldn't want to lose it completely, but negative 1, comma, 11 over 5. Any questions there?
It's not a bad idea when you have to type in 2 answers. Type one's an integer and one's a fraction. Type the integer first.
Then you don't have to worry about the comma and the
I should be
denominator.
quiet because
They'll come to a point where they have to put them in numerical order.
So forget it. Ignore everything I just said. We've lost the internet, so I'm going to pause this right now, and we're going to connect to the Wi-Fi, the faculty Wi-Fi. We'll see how that's going. Okay, so let's type in those answers. Negative 1, comma,
11 over 5.
11 over 5. Okay. So, and that's really what we did the last time, okay?
Factoring to solve quadratic equations. Any questions there? So, Roman numeral 1, we said factoring, and that's from the previous assignment. Roman numeral 2, the square root method.
This is new.
Okay. This is new.
By that I mean we haven't already done it, like the factoring.
The square root method. The square root method says that if you have some quantity squared, if x squared is equal to a number n, then x has to equal the positive or negative square root of that number.
And if they stop and think, what about x squared equals 25?
Yeah, I was going to say, I bet you that this is something, if you think about it, it should seem pretty obvious. Here's an example. X squared is equal to 25. Which numbers, you're asking yourself, which numbers can I square to give me a positive 25? There are two of them. 5 and negative 5. That's what this thing is saying. If it's in the form, something squared equals a number, you can drop the square on one side, but you have to pick up a positive and negative square root on the other side. And the square root of 25, well, that's 5. So our answer is positive or negative 5.
Now let's look at number 4.
For the square root method, you need the equation in the form something squared equals a number.
Oh.
Did you click there to go to number 4?
I hit the arrow to go to number 3 and then number 4. Okay, so we've done number 3. It's going to
go straight to number 4 now. We've already done 3.
Okay.
This is number 4. 4 times a squared is
squared.
What made me think it said a? 4 times x squared is equal to 8. We need this equation. If we're going to use the square root method, it needs to be in the form something squared equals a number. Well, what's the base of that 2? What's being squared here? I guess my question is the 16 being squared?
The 4.
I mean, is the 4 being squared?
No.
That square only applies to x. So we need to, if we wanted that 4 being squared, you would have had to have the problem written like that, where the 4 and the x were enclosed in parentheses. That's not what we have. We can get rid of that 4 by dividing both sides by 4. That gives me x squared is equal to 2. Now this is tailor-made for that square root method. We have something squared on one side, a number by itself on the other side. So you drop the square on the left, you pick up a plus minus square root on the right. What about the square root of 2? Can we reduce that? No, 2's not a perfect square. 2 is a prime number. You can't reduce the square root of 2. So you're going to type in positive or negative square root of 2. I remember about 6 years ago when they introduced the plus minus hot button. It used to be you had to type in square root of 2, comma, negative square root of 2.
Here's how we used to have to type it in. Square root of 2.
Get out of the denominator.
Comma, negative square root of 2. Now, if you miss it, you get an answer wrong, the way it's going to say this is the right answer, okay, because that's how they used to do it.
They used to state it as 2 answers, but you're not going to be doing that now thanks to that hot button. Delete that and put in.
So, go plus minus
the square root
of 2. Sometimes students say, oh, they counted it wrong because I used the plus minus.
No, you did something else.
You did something else wrong.
Any questions there? Number 5.
X squared equals a number. Number 5 is 3x squared plus 21 equals 0. It's got to be in that form. X squared equals a number.
You know, 3x squared plus 21. This is interesting. Switch to my paper. When you're factoring, if you're solving an equation by factoring, your solution is going to be 2 rational numbers, either an integer or a fraction, but you don't pick up square root symbols. You don't pick up imaginary numbers when you're solving a quadratic equation by factoring. Here, The square root method, well, it gets the rational number solutions. It also gives us irrational solutions. That square root of 2, that's an irrational number. This thing here, if we're going to use the square root method, the only thing being squared is that x. We need to get that x squared by itself. What will we do first? Subtract 21, I agree. We'll subtract 21, and that'll give me a 3x squared equals a negative 21. And then what do we do? Divide both sides by 3. You're trying to get x squared by itself. So you have x squared equals, what have we got on the right-hand side? Negative 7, I agree. Now this is the form we want. Quantity squared equals a number. If you had a negative 7x there, you couldn't use the square root method. You have to have something being squared by itself on one side, a number by itself, not a variable, but a number by itself on the other side. Now we're ready to use the square root method. You drop the square on the left. What do you pick up on the right? A plus or minus square root of negative 7. And if you type this in, my lab will count it wrong. We know what happens when you have a negative number under a square root. What do you have to do? I. You're going to have to write it using an I. Well, 7's a prime number. You can't bring anything else out. All you can do is you can think of it. Here's my thoughts. I'm thinking of it as the square root of negative 1 times the square root of 7. That's my thoughts. And remember, the square root of negative 1 is an I. The square root of 7 just remains the square root of 7. So plus or minus I times the square root of 7. The square root method, not only can they give you irrational solutions, they'll give you imaginary solutions as well. If you're solving a quadratic equation by factoring, if you're going to be able to solve it by factoring, the solutions have to be rational numbers. No square roots and no i's. Any questions there? Let's go ahead and type in our answer. Click the plus minus
Talks
hot
about
button.
using a comma because that's what it
Used to do. But now we don't have to type separate answers. We have that plus minus hot button. So we put an I. And you'll notice there's not even an I on the toolbar. You don't need it. If you have a need to enter an imaginary unit I, just type the I from your keyboard.
Use a lowercase letter, not a capital. Never use capital letters.
Any questions there? Number 6.
Oh, it's a multiple choice one. And I won't let it, here, I'll do this. There.
6.
I hit all the choices.
Good for you. 3x minus 1 quantity squared is equal to 21. They want us to use that square root method again, but this problem looks mighty different from the others. Okay, switch to my paper.
You keep saying quantity squared rather than just x
That's
squared.
why I keep saying quantity. You have to have something squared, a quantity squared on one side, a number by itself on the other side. This number 6 is not like number 4 or 5. We don't have to change up the equation. We're able to apply the square root method immediately because it's already in the desired form. Quantity squared on one side, quantity squared equals a number. We already have it. We have it in the desired form. We can drop the square on the left, so we just have a 3x minus 1. What do we pick up on the right? More than a square root. Plus or minus square root of 21. Are we going to have an I in our answer? No. Is 21 a perfect square? Can we reduce the square root of 21?
3 and 7, there's no
3 and
point.
7 are the only factors other than 1 and 21.
Wow, so you're just now doing exactly what we were doing
on the very
first day of the semester.
Reduce,
builds
the
and
problem
builds.
is we missed all last week. That's why it seems like it's so long ago since we've done this stuff, because we had that whole week off. So thanks to the big freeze. But the square root of 21, my question was, can we reduce it? And y'all's answer is no. Okay, work with the plus minus as if it's just a plus or just a minus. We need to get x by itself. What are we going to get rid of here on the left side? What will we do first? Add 1. Move that 1 over and stick it in front of the plus minus. That's just standard practice. When you move that constant over, that negative 1 becomes a positive 1 plus or minus the square root of 21. And then what can we do? Divide by 3. You know what I need to do? We need to go through a discussion on how we're going to perform these reductions, how we're going to reduce these messier answers. Because if there's an I, if that had been a negative 21 and we had had an I, we'd have to separate it the way we did in assignment number 2. Okay? Y'all remember this stuff here? We had a sum or difference with an integer on the bottom. You have to separate when you have an I on top. If there is no I on top, what you have to do is look at the 3 numbers outside of the radical. You say, well, I don't see a coefficient on this first square root. Sure, it's a 1. You have to have 3 numbers, and then you ask yourself, is there a common factor? Well, 1 and 3, the only thing that divides evenly is a 1, so this is the form they're looking for. We'll discuss this reduction more in a moment.
Let me type this in. Oh, wait, I don't think I have to type that in. It's a multiple choice. Let me see. Let me move this so y'all can see all the answers. Well, still can't see. Is it D?
1 plus or minus the square root of 21 over 3.
What was A? Oh, did I have the plus minus, just a plus?
And C didn't have the plus minus. The only answer is D.
Oh, what did they do? They added, no, they subtracted the 1 and the 21. That's how they got the 20.
I think it's terrible looking at what they did wrong. It puts wrong ideas into people's heads.
Well, before we go on,
you know what I think we need to do? We need to practice. Some of these fractions like this are going to have I's on them. Those are the ones you'll have to separate and reduce individually. The others are not going to have I's, and you're going to have to factor and cancel. So I want to compare. I want to look at how we're going to be reducing our answers. Reducing answers. I have 2 problems here. They're very similar. Where is it? Okay. 8 plus or minus 14i square roots of 6 all over 4. I want to compare that one. Suppose there isn't an I. Suppose it's just 8 plus or minus 14 square root of 6 all over 4. If your answer has an I in it, they're going to want you to write your answer in standard form, A plus or minus BI. That means 2 separate terms. You can't leave a common fraction. Well, we know what to do. You just separate 8 over 4. Do y'all remember doing this? Plus or minus 14i square roots of 6 all over 4. Y'all remember separating these things? And then you reduce individually. This is nice. 8 divided by 4, what's that going to give us? 2 plus or minus. Now look at this thing. We can reduce something. Remember we said you cannot cancel something under a radical with something that's not under a radical. But you can look at the 14 over 4. Both of those are divisible by what number? You have the fraction 14 fourths. What can you cancel above and below? A 2. 14 divided by 2 is 7. 4 divided by 2 is 2. So here's the answer that you would have to enter. 7, don't forget the I square root's of 6, all over 2. If there's an I on top, you're going to have to separate them and reduce the fractions individually. They want the imaginary answers in the form A plus or minus B times I. B is 7 square root of 6 over 2 times I. Suppose there isn't an I. Here's the new thing. And this number 6 wasn't a good example because there was no common factor to factor out. Okay? But now let's look. Look at the 3 numbers. So if you're going to reduce this, there has to be 3 numbers outside of the radical. Here there was only 2, so certainly you couldn't reduce. 14, 8, and 4. All 3 of those numbers are divisible by what number? They have a common factor. What is it? 2. So you're going to divide by 2, divide the 14 by 2, divide the 8 by 2, divide the 4 by 2. 8 divided by 2 is 4, plus or minus. 14 divided by 2 is 7 square roots of 6, all over. What's my denominator going to be? 2. And don't start going cancellation crazy. You can't cancel over those plus minuses. You can't cancel over addition or subtraction. The way we're canceling here, that's why we split up. Because you can't cancel over addition, subtraction. What you're doing, I'm going to show you what the logic is here, but I'm not going to be doing it. Here's the way you would want it reduced. Here's that 8 plus or minus 14 square roots of 6. Hold on. There. What they're doing, you said 8, 14, and 4 are divisible by 2. I'm going to factor out a 2. 8 divided by 2 is 4, plus or minus. 14 divided by 2 is 7 square roots of 6, all over. Well, you have that 4 there. And then, because you've written a product, you can say 2 goes into 4 2 times. I don't think I'll be showing this step each time. I'll figure out what's the common factor, and then you divide those 3 numbers by that same common factor. 8 divided by 2 is 4. 14 divided by 2 is 7. 4 divided by 2 is 2. Any questions there? If there's no I, we're not going to be splitting up. We're going to factor and cancel. And if there's no common factor, then that's even better. You don't have to do anything. Just stop right there. But if there's an I, we're going to be splitting up and canceling the fractions individually. Any questions there?
Let's do number 7.
Let's do number 7.
Find out.
If we haven't already been.
Oh shoot, I think I just clicked on.
There it is. Did you choose? Oh, it's another multiple choice. Okay. This is number 7. Let me write the problem down. Oh, z plus 2 squared equals a negative 11.
And I was new at teaching it, Dawn. I learned something pretty fast. Back in the olden days with paper tests, there'd be problems that students would miss, and I'd be like, what the heck is going on? Why are they missing this one?
Where are they getting it for?
Or
the Z's.
Z's become 2's, and S's become what? What do y'all think of S? 5.
B is the worst. If there's the B becomes 6, and so
here it's just we can't control it.
We can't control the variable. But if I ever achieve world domination, I tell you right now, that will be my first. I'll be a
Executive
benevolent
order.
world leader, but my first executive order will outlaw variables B, S,
S, Z.
Z.
I don't like T's either. It looks like a plus.
I'll tell you what else I don't like. I don't like letters that have tails on them. A Y, the tail runs down
Okay,
to
Tim,
the next.
enough.
Oh well, but
Did you write down the problem?
yeah, I'm waiting for them to tell me what to do.
Oh, okay.
Do I have to manipulate this? Do I need to move terms around, or can I just start with the square root method? Is this in the format that we need? It's in the format. Something squared equals a number. The thing that's being squared, it can be more than just one term, like on number 6. It can be a sum or difference, but it's in the desired form. Something squared equals a number. We drop the square on the left. What are we going to pick up on the right? Plus or minus, what else? Square root. And look at that negative 11. What are we going to have to do with that square root of negative 11? Okay, we're going to have to move that negative out, and that means we're going to pick up what letter? An I. That's right. So we have a plus or minus I square root of 11. Any questions? Because at this point, there's only one remaining step. What is it? We need to get Z by itself. Subtract 2, so we're going to have Z equals, and it's standard practice when you move that constant over, put it on the left side, put it before the plus minus. And it's not even a fraction. We don't have to worry about splitting up and canceling. It's not even a fraction. Negative 2 plus or minus I square roots of 11. Any questions there?
Oh, wait, it's multiple choice. I think this is only 3 choices.
If it's a multiple choice problem and you only have 3 options, they only give you 1 chance to select the right answer. If it's 4 options, they'll give you 2 chances to select the right answer. But here there's only 3, so you better get it right.
Or else you got to say a similar question and do it again.
Okay. Yes, y'all should be trying to make hundreds on every homework assignment. If you get a problem wrong, you say similar question and you do it again. Okay? Your goal shouldn't just be meet the prerequisite to go on. Your goal, 100 homework average, the homework average counts 20% of this course grade. And trust me, 100 homework average goes a long way to raising your overall course average.
Versus the 80 homework average, would be 5 points. 5 points.
There's a 5-point difference versus with a 100 homework average versus an 80
Now, do you want to do a little talking before we move on to the quadratic formula?
Roman numeral 3. Any questions? What about in the peanut gallery? Those of you over there. Okay, now realize if you just are sitting over there just because your schedule said room 303, you feel free to move over here if you want to be closer. And if you want to be away from us, then you feel free to move over there.
Although I must confess, when this computer was messing up, so I was very tempted to move over there and see what's going on. But generally, if the internet is messing up on this computer, it'll mess up on that one. Because we have a wired internet. That's what we're supposed to be using, not the Wi-Fi.
It's more secure.
Yeah, it's more secure.
Okay, I'm ready to go. Roman numeral 3. I said we're going to see 3 methods of solving quadratic equations in this class today. We'll see another one later on, completing the square. But right now we've seen factoring, we've seen the square root method, and finally we have the quadratic formula.
This is a formula that will solve any type of quadratic equation.
It'll give you imaginary solutions. It'll give you irrational solutions. It'll give you rational solutions if you just can't see how to factor something. Okay, I'll say any solutions to the quadratic equation ax squared plus bx plus c
equals 0.
equals 0, thank you, are given by x equals...
What he's about to write is what some people think of as the quadratic formula. If someone walked up to you and said, tell me the quadratic formula, what they want you to say is right here what he's about to write.
It's the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a.
Okay.
The thing underneath this radical is called the discriminant. If the discriminant reduces to be negative, what sort of answer are we going to have? We're going to have a letter in our answer. If that thing under the square root turns out to be negative, what letter will we have? An I, that's right. If the discriminant is negative, you're going to have an I. If the discriminant turns out to be a perfect square, something like 25 or 36, are you even going to have a square root appearing in your answer? No.
Square root of a perfect
square. If that discriminant, the thing under the radical, turns out to be a perfect square, then that means you could have solved the equation by factoring. Because the factoring equations are the ones that, the factoring problems are the ones where you don't pick up any square roots or i's. But what's nice is, suppose you're trying to solve an equation by factoring and you just don't see the factorization. You don't see how to get it done. The quadratic formula always works. Even if you can't see how to get it factored, you can use the quadratic formula and get the solutions. So with that in mind,
let's do number 8 before I get timed out.
I remember once having a teacher was complaining, a co-worker was complaining because there's those tails, that Y has that tail, that little curvy tail is going to be messing up the line underneath for my writing. Oh, maybe I should have started on another page. Well, see what I mean? That's why once I take over the world, I'm going to stop. That's one of the things.
Well, when I take over the world, my executive order, my second one, will be you can't write Y with a curvy tail. It's just going to be a little straight line.
If it's a single variable, it must be X. I think that'll solve it. You only use curvy tail letters if you've used all the other letters in the problem.
I think they're getting scared.
Okay, but still.
Let's write out, first of all, let's look at the equation.
Just like with factoring, the equation needs to be in descending order on the left side and 0, or on one side and 0 on the other. Sometimes I'll get 0 on the left. You'll see me doing that before the class is over, but you have to have descending order on one side, 0 on the other. Is that what we have? No? What are we going to have to do to get this in the desired form?
Add 26.
Add 26? I agree. So that's going to say y squared minus 14y plus 26 is equal to 0. And now we're going to identify a, b, and c. I always have people saying a is y squared. No. A is the coefficient on the variable. I don't see a number in front of y squared, so what do we assume the coefficient is? 1. Our a value is 1. What's our b value? Realize the sign is that minus is the sign on that coefficient. The b value is negative 14.
That's what I heard.
I heard it too. And what is c?
26.
A positive 26. And I'm running out of room. Normally I'd recopy the quadratic formula, but it's sitting right there above the problem. So I think for this one time, I won't bother recopying it. So we have x equals, I'm drawing my big fraction. Oh, y equals.
You don't have to say anything equals. You could have just written the fraction bar.
Y equals this first term, negative b. That's saying the opposite of B. Change the sign on B. What's the opposite of negative 14?
Positive.
Positive 14. Plus or minus the square root of B squared. 14 times 14, that's 196.
I encourage you for doing the B squared, always just do that either. Usually it's numbers you can do in your head, but here 14 times 14, you might want to use a calculator. But if you are using a calculator, make sure you don't do what I'm about to do.
Look at what he just did on that calculator.
Negative 14
Negative times
squared.
negative has what sign? We know that. Negative times negative is going to be what? Positive. But
What
look
did
at
I
what he
do
just
wrong?
now punched in. He punched in negative 14 squared and got a negative because he didn't enclose the negative in the
This goes back to
parentheses.
what you were
If
saying
I were
the other
you,
day. I mean, yeah,
this
earlier.
B square is always going to be positive. So all you got to do is square 14. I knew 14 times 14 was 196.
But earlier, as I was saying, you mentioned that the square applies only to what's right beside it. The
That
square
negative
applies
is-
only to the 14, not the negative.
That's right.
If you want your calculator to give you the correct answer for negative 14 all squared, you gotta put it in parentheses.
But that's too much work. Just remember, B squared will always be positive, so just square the number part. 14 times 14 is 196. And then we have minus 4 times 1A times C. C is 26. All over 2 times A. What was A? 1, 2 times 1 is 2. Simplifying that discriminant, let's see, 25 times 4 is 100, and so 104, so that's a 196 minus 104.
So you're simplifying under the square root. That's what I've punched in there.
And that's going to give us a 92. Of course, it could have been. I was thinking it might be a perfect square to get it started, but no. So it's 14 plus or minus the square root of, I forgot what it was.
92.
92.
Are we going to have an I in this answer? Say no.
No,
No,
because this number under the radical is not negative, so we're not going to have an I. Is 92 a perfect square? Is 92 a perfect square? No. What's the largest perfect square that divides evenly into 92?
Starting with 81 doesn't.
81 doesn't. 64 certainly doesn't. 49, no, that doesn't. 36.
4, the only one that does it.
Let's see.
16 does it. Yeah, I'm agreeing with you. You're right. You're ahead of me. 4 times 23.
So here's what we're thinking. Remember how we reduce these square roots. For 92, we think to ourselves, that's the square root of 4 times the square root of 23. So we have 14 plus or minus. What are we going to do with that red square root of 4? We're going to make that a 2. And what are we going to do with the square root of 23? Leave it. Move it up. There. And we still have a denominator of 2. This is one of those problems I was talking to you about earlier. Notice, we have 3 numbers outside of the radical. 2, 14, and 2. Those numbers are all divisible by what? 2. So we're going to divide everything by 2. Divide by 2, divide by 2, divide by 2. That's going to give us a 14 divided by 2 is 7, plus or minus 2 divided by 2, that's just 1 square root of 23. Hey, what have we got in the denominator?
1.
2 divided by 2 is 1. So you don't have to write that. Here's the answer. 7 plus or minus the square root of 23. Any questions on my logic there?
7
Plus or minus
the square root of 23.
Any questions there?
Mhm. We ready to do the next one?
I think so. Any questions? Number 9.
Oh, Is it in the standard form that we need it to be in, or are we going to have to move the stuff around?
Let me write it down first.
Okay, write it down. 2x squared minus 7x equals 1. Wow, it's only been going on 51 minutes. It seems a lot longer.
Well, we had to stop and try to get the internet
I know.
working. Okay, there's really only one correct first step. Whether you're going to try to solve this by factoring or the quadratic formula, there's only one correct first step. What is it?
Subtract 1.
Subtract the 1. You need it descending order on one side and 0 on the other. So we have a 2x squared minus 7x minus 1 equals 0. Now let's identify our, well, first of all, let's write out the quadratic formula. I want to have something to look at or to point at. So we have a negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm going to let y'all tell me a, b, and c. What's a? A is the coefficient on x squared. What will a be? 2, I agree. B is the coefficient of the x term.
7.
No.
Negative
Positive
7.
of
Remember,
negative
take the sign. Negative 7. And C, I couldn't hear you. Negative 1, I agree. Now let's start making the substitutions. Okay, so we have oh goodness. The opposite of B, the opposite of negative 7 is positive 7. So we have a positive 7 right there. B squared. You take negative 7 times negative 7 is going to be a positive 49. 7 times 7 is 49 minus 4 times A times C. So we have a 49 and a plus 8. That negative times negative would become a positive 8. 49 plus 8. I'll write that down in a minute. What have we got in the denominator? 2 times 8. What am I going to have down here? 2 times, I couldn't hear you.
2 times 2 equals 4.
Okay, good. 2 times the a value of 2 gives me a denominator of 4. And so we have a 49 minus 4 times 2 times negative 1. I said that that was a positive 8. 49 plus 8. Wait a minute.
plus minus.
Oh, plus minus, thank you. 49 plus 8 gives me a 57. Is 57 a perfect, well, first of all, are we going to have an I in our answer? No, we won't have an I because that number under the square root is positive. Is 57 a perfect square? No. If it were, that would mean that 2x squared minus 7x minus 1 is factorable, and it isn't. So, can we reduce the square root of 57? My first thought is no. I'm thinking of the factorization of 57. Isn't that just a 3 times 19?
Oh, yeah.
I don't see.
There's no other numbers that multiply together. Certainly no perfect square.
Oh, here is.
57.
Where's my list of perfect squares?
Oh, it's up to 25. No. 16, no.
9,
9, no.
Certainly not 4.
4, no.
So that means we can't reduce the square root of 57. If we can't reduce the square root of 57, that means we're not going to have a number right there where I'm pointing. And if we don't have a number right there, can we factor and cancel? No. Here's our final answer. Don't separate or split up. There's the final answer.
Now,
You leave it like that.
If you get it wrong, here's what they're going to do. When they say the right answer, they type it without the plus minus. They go like this: 7 plus the square root of 57 all over 4. Then move over and put a comma, and then write another fraction, 7 minus the square root of 57 all over 4. Why do they do that? Because 10 years ago that they didn't have a plus minus key built in. Okay? And even though they've added the plus minus key,
They still
they
have
haven't
it
changed.
programmed
Yeah.
to list the answers separately.
So if you look at one where, does that mean you shouldn't use the plus minus key? Well, of course use it. I just want you to see that this is another way it could be entered. It's how it used to have to be entered. Okay? Number 12 now. Okay.
Mm-hmm. Oh, goodness. I'm always surprised when my little hotspot works on my little 5-year-old phone.
I'm really
Where
surprised about it.
equals 2x minus 10.
Oh, go back to the quadratic formula. And put the statement. We talk about a positive. 4x. Okay. Just like with factoring, say it.
I said when I was writing it that, A is positive. We want that A value to be positive, and if it isn't positive, we're going to do something about it. When we look here, we need 0 on one side. Well, the quickest thing to get 0 on one side is to pick up that x squared and move it to the left.
Right.
To the right. If you pick up that x squared and you move it to the right, you're no longer going to have a 1x squared. What would you have? You have a negative 1x squared. You have a negative a value. So my advice to you, do not move terms around in a way so that you get a negative a value. You want that to stay a positive 1x squared. I'm going to get the 0 on the right-hand side. I'll have an x squared. I'm going to move that 2x over by doing what?
Subtracting.
So we have a minus 2x. What am I going to do about that minus 10? Add 10
Good.
to give me that equation there. When you're moving the terms around to get 0 on one side, make sure that you keep the leading coefficient positive. So with that in mind, let me write out the quadratic formula again. Negative b plus minus the square root of b squared minus 4ac all over 2a. Let's determine our a, b, and c values. What's my a value? 1. B, negative 2, I agree. And C, 10, I agree. Let's start plugging in now. Negative b. It seems like b is negative in every example we're doing. And then when we change the sign, it becomes what? And so it'll become a positive 2. Eventually, we will have some where b starts off positive. And when you make it negative, you have to add on that negative sign. This negative b is just saying change the sign on b. Whatever, b is negative here, so we're making it a positive. B squared, negative 2 times negative 2. What's that going to give me? B squared, 2 times 2 is 4. Remember, b squared will always be positive. Minus 4 times a times c. A was 1, C was 10, so we're going to have a 4 minus 40. We'll deal with that in a moment. What's our denominator? Let's write down the denominator. 2 times A, 2 times 1 is just a 2. Now working under the square root, simplifying there. 4 times 1 times 10 is 40. So you have 4 minus 40. That's a negative 36. Tony, does your calculator agree with my mental arithmetic?
I'll point out the mistakes. I would have told you if you've done it wrong. Oh, gosh.
Probably you would have entered it wrong and it'd be your mistake.
Yeah, probably.
Okay. Wow, this is nice. Look at this answer. Well, first of all, what do we, when I look under that discriminant, I think of a letter that's going to appear in my answer. What is it? An I. But what's the square root of 36? 6. So we're not even going to have a radical. We have 2 plus or minus 6i all over 2. Any questions there? The fact that it's negative means we need an I. The square root of 36 is just an integer 6. Okay, we have a sum or difference over an integer. We split up. If you have an I on top, that's when you go 2 over 2 plus or minus 6i over 2, and this sure reduces nicely. 2 divided by 2 reduces to 1 plus or minus 6 divided by 2 gives me 3. Don't forget the I. Good.
Can I get a 4 out of that? The 1 plus 3, can I make that a 4?
No, you cannot. You cannot combine the thing without the I with the thing that has an I. Just like you can't combine something without an X to something that has an X. 1 plus or minus 3i.
Check the answer.
Okay. It's that. And now I'm going to let Tony take over. I remember when a colleague said, once was talking, the students couldn't memorize the quadratic formula, and I was like, really? You don't just write it over for every problem when you're using it. And this person told me, looked at me like I was an idiot, and said, I can't do that. You can't recopy the quadratic formula every time you use it? No, I'm not going to do that. No, okay. They don't work here anymore, do they? No. Okay. R squared plus 3r. Oh my goodness, how to make a good first impression. I've already miscopied it. That should be a minus 5. I wrote a plus 5. Oh, yeah. R squared plus 3r minus 5 equals 0. I am. I'll write down the quadratic formula. negative b plus minus the square root of, oh, you know what I should have done? I should have asked, are we going to need to move anything around or is it in standard form? Ignore that mess right there. Just supposed to be a minus 5. I'd written plus 5. But is it in standard form? 0 on one side, r squared, r constant. It's in standard form.
They're ready to identify the
A, B, and C.
Yeah.
So let's see. Let's write out A equals, B equals, C equals. What number is A? A 1, that's right. B, 3. It's a positive 3. And C is negative 5.
Oh, finally we have a B that starts off positive. Okay.
So now we'll start plugging in. Let's see. Negative B. Well, changing the sign on B, changing the sign on 3, you're just going to get a negative 3. Plus minus.
What are you going to get for B squared?
3 times 3 is
9, okay.
And then we have a minus 4 times A times C all over. All over 2 times A. We can do that in our head. What's 2 times 1? 2.
Working under the radical, it looks like you have a 9 plus 20. You have a 9 minus 4 times 1 times, if you're using a calculator like this, you better make sure, realize this calculator has a separate minus key from a negative key. That thing there in front of that minus, that 5 is not subtraction, it's a negative 5. Now mathematically we say the same thing, we say minus 5, but technically when you're punching it into a calculator you got to use the negative key. That's one of those things we hadn't mentioned before now. But 9 plus 20, you couldn't get a much nicer discriminant. What are you going to have under that discriminant? 29. Are we going to have an I in our answer? Are we going to have to reduce further? To reduce further, you have to be able to reduce the square root of 29. Can you? Plus minus.
Oh my gosh, I did it too. Plus minus.
Can we reduce the square root of 29? 29 is a prime number. You cannot reduce the square root of 29. There's no I, so you don't split up. You leave it as a single fraction. Any questions there?
On the 9 minus 4 times 1 times negative 5, when you're calculating it, are you doing 4 times 1 times negative 5?
The order of operations is multiply before you add and subtract. 4 times 1 is 4 times negative 5. We have negative 20, but another minus here makes it a plus 20.
Or you can think of it as a negative 4 times 1 is negative 4 times a negative 5 is a positive 20. You have 9 plus 20 under that radical.
Okay. Got it.
Okay. Did you punch it in? Negative 3
plus or minus
square root of 29 over 2.
Any questions there?
Well, 14 and 15, only 2 more that I was planning to do. Oh, I like number 14. Negative 5x squared equals
negative 15x plus 13.
negative 15x plus 13. Is this
I've noticed something. If they tell you to use the quadratic formula in the instructions, that means it's not factorable.
Oh,
But if you were able to solve by factoring, you'd still get the same answer. Okay? But
number 13, show this piece of paper.
oh, number 13. Oh, there.
Could you have gotten this answer by factoring? No. This is one that could not have been factored. None of the ones that we're using the quadratic formula on could be factored. Sometimes students ask on a test, it says solve using the quadratic formula, but I wanted to factor it. I factored it. No. If the instructions say use the quadratic formula, that's the way of saying it will not factor. Don't spend time trying to factor it. Okay? Now, the thing that's wrong with this number 14 is, first of all, there's not a 0 on one side. And if I take all of this stuff and move it to the left, we're going to have a negative a. It's always, always best for a to be positive, whether you're factoring it or using the quadratic formula. So in order to get a 0, this is the first time today it's happened, it'll pop up. Usually we get 0 on the right, but sometimes you just got to get the 0 on the left. I'm going to move this over here so that I have 0 on the left and a positive 5x squared on the right. Then we still have the minus 15x and the plus 13. Are there any questions? Y'all see how I've rewritten it? This is really you don't want A, B, and C to be, you don't want A to be negative. It doesn't matter if B or C is negative. And if you think about why that is, do you ever want a negative number in the bottom of a fraction? No. If A had been negative, I'd have a negative number in the bottom of the fraction that I'm going to have to try to get rid of.
Then to get rid of it, you then have to multiply the top and bottom by a negative 1 all the way across. So that would change the sign on the first number here. The plus minus would become a minus plus, which is still a plus minus.
But why would you want to go through that? So I'm going to write down the quadratic formula. And we'll start plugging in. If they're in, well, we won't plug in yet. We got to write out A, B, C.
What's A? 5, okay. B, negative 15, okay. C, okay.
A is 5, B is negative 15, C is 13. Okay, so negative B. B is a negative 15, so negative 15 is just 15. Minus B means change the sign on B. Plus minus the square root of B squared. Well, punch that into your calculator if you can't do it in your head.
15 times 15 is 256. Oh,
no, 225.
I mean 225. Oops, I messed up on something. 15 squared there. 220. Damn it.
Darn it.
I'm telling you. 15. I know what I'm doing. I'm using that thing. I'm used to using the caret top and the 2. You see, I'm used to that caret top. If I want to square something, I put the caret top and the 2. If I want to cube something, caret top and the 3. So that's why I keep messing up. thinking of the Carrot Top. I was trying to use that X square key.
Minus 4 times A times C.
What's A?
5. And C is 13. All over 2 times A. Now 2 times A, we can do that without a calculator. 10.
220.
Okay.
So it's 225 minus 260.
20 times. Did y'all hear that? All of this is going to reduce to a negative 35 because it's 225 minus 260. Okay. Hey, are we going to have an I in our answer? Yes, is that what I heard? So we have 15 plus or minus that square root of negative 35. Well, because of the negative under the square root, we have an I, but can we simplify square root of 35? What are the only two numbers that multiply together and give you 35? 7 times 5.
Other than 1 times 35.
Well, I know, but 1 and 35 wouldn't have helped reduce it. So 5 and 7, those aren't perfect squares. So what are y'all telling me I need to do with that 35? Do I leave it under the square root or am I going to change it somehow? Just leave it there. All over 10. Oh, wow.
But you can't enter that as your answer. It's an imaginary number, a complex number. They want in the form A plus or minus BI, so you split up.
If this had an I, we'd be finished with it because there wasn't 3 numbers under the square, 3 numbers
like
outside without a square root.
If there hadn't been an I, it'd be like this number here, number 13, we'd be through. But because of the I, we have to split it up.
So we have 15 over 10 plus or minus I square root of 35 over 10. Don't let it trick you and think you can do something with the 35 and the 10. You can't. But what about the 15 over 10? What can I divide both of those numbers by? 5. So we'd have a 15 divided by 5. 3 on top and what on the bottom? 2. So it begins to, so maybe you see why we're talking about the different ways you simplify. If there hadn't been an I, you would leave it like this and stop like you did up here. But because there's that I, you've got to separate it, or else it's going to count it wrong. Okay, and reduce.
Because it's standard form for things with I's. Sums or differences with I's to put the thing that doesn't have an I before the plus minus and then the thing with the I. That's your standard form.
Go ahead and plug.
So we have a 3 halves. Get out of the denominator, plus or minus. I'll use my fraction hot button there. We have an I on top, a square root of
35.
35, and on the bottom we have a 10. Any questions there?
It's significant. There is the stuff that he was writing about how to reduce the fractions. It really is important. If there's no I, you would have left it like you did over here. But because of the I, you've got to know to separate it like that. Okay? Sometimes separating and canceling doesn't really give you a different answer. Like, if you, like on this one, number 8, Tim, show the screen. If number 8, if you had canceled it wrong, if you'd separated it, you would have still gotten the same answer. 14 over 2 is 7, 2 over 2, 1. But for some of them,
If you cancel it the wrong way, it's going to count it wrong. Leaving it like this, wrong. Okay. Now, before we do 15, I just want to review multiplication of fractions. Multiplication of fractions. Suppose we had something like this. 7 over 5 times 10 over 9. The rule for multiplying fractions is you multiply straight across. So if you just multiply it straight across, you'd have a 70 on top and what on the bottom?
40.
And then you reduce from there. Oh gosh, what number divides into both 70 and 45?
5.
A 5? Okay. 70 divided by
14.
5, is that a 14? 45 divided by 5 is 9. So that's the formal definition of multiplication of fractions. You just multiply straight across and cancel. But you might recall, and you can do this only with fractions, multiplication of fractions, cross-canceling, like looking at the 5 and the 10, looking at those two numbers, both of those are divisible by 5. So if we divided out of 5, 5 divided by 5 is a 1, 10 divided by 5 is 2. Now this other diagonal, there's nothing to cancel there. 7 and 9, the only thing that divides into both of those is a 1. So we'd have 7 times 2 is 14. 1 times 9 is 4. So you can either...
No, 1 times 9 is 9.
1 times 9 is 9. Where'd I get a 4? Oh, wow.
You're thinking it's almost 4 o'clock.
Yeah, I want to be through by then. So you can either multiply straight across, then cancel, or cross cancel. The advantage of the cross canceling is sometimes multiplying straight across, the numbers might get really large. Okay? What about this one? Let's make sure, how about 2 over 3 times 15? How do we multiply a whole number or an integer and a fraction?
Put it over 1?
Yeah, you can think of that 15 as over 1. And I'm going to do the cross-canceling stuff here. What could nothing there cross-cancels, the 2 and 1.
Okay, y'all tell us, what can he cancel?
3.
The 3. Okay, he can cancel the 3.
3 goes into 15. What number am I going to put right here? 5. And is my answer going to be just an integer or a fraction? What's my final answer going to look like?
Is he going to have a denominator in his answer?
We have a 10 over 1.
Over 1, so
We
no
don't need-
denominator, it's just an integer.
So to multiply a fraction by integer, think of that integer as over 1. And if you can cross cancel, that's what I'll do. Okay? How about one more? Negative 5 over 6 times 24?
Yeah.
Is that a good one, Tim?
Mm-hmm.
I think of it as 24 over 1. Are we going to have a fraction as our answer or an integer here?
Can he cross cancel something? What?
6.
The 6,
6.
okay, 6 divided by 6 is 1. 24 divided by 6 is 4. What's that going to give us as a product?
Negative.
20, I agree.
Now, why did he want to remind y'all of how you cross cancel?
First of all, is it difficult? Is this really that hard, cross canceling like that? I don't think it's that difficult. Looking at number 15, do you think I have room for it here?
I wouldn't.
Go to a new page.
Mm-hmm.
Oh, you know that's a good one. Okay. Okay, number 15. 1/3 x squared. When I write it, I'm going to spread it out a whole lot. Well, you know what? I have a whole sheet of paper. I'll just wait and do that in a moment. So,
-1 equals 0.
okay, there. 1/3 x squared plus 1/15x minus 1 equals 0.
It says solve using the quadratic formula, and I think it's in the acceptable form the way it's written. We have descending order on one side, 0 on the other. The a value is positive, but who wants to have an a of 1/3 and a b of 1/15 and a c of -1?
I don't mind the c of -1,
I don't mind
but that a equal 1/3 and b equals 1/15, that's going to be pretty messy. So to avoid, what I would rather do, I'd rather do a little bit of this multiplying and get rid of the fractions than a equals 1/3, b equals 1/15, c equals -1. When you have an equation, you can multiply or divide both sides by anything you want, except for 0. Why would you multiply by 0? If you multiplied everything by 0, you've gotten rid of everything. So
now, if you multiply both sides, say you multiply the left side by something, there are 3 terms here. 1, 2, 3. Remember, terms are separated by pluses and minuses and equal signs. So there are 3 terms on the left side. You're going to have to distribute what you multiply over all 3 terms. So
I'm thinking to myself, I like this cross-canceling stuff here. The way the 3 canceled with the 15, so there was no fraction, and the 6 canceled with the 24, so there was no fraction. What one number could I multiply straight through by that would cancel both this 3 and this 15? Like a 3 would cancel out this 3 here, but would it completely eliminate this denominator? What number could I multiply straight through by that would get both of these to cross cancel?
think back to working with fractions. If you had 1/3 plus 1/15, you'd have to get a common denominator, and you'd call that denominator the least common denominator. That's what you're looking for. What would be the least common denominator for those fractions?
15.
I think I heard it. 15?
If I look
didn't see who said it, but I think I heard it.
Right there, number 15.
Okay.
I mean, 15. If I multiplied straight through, look at how I'm going to do this. By 15,
he's distributing the 15 over all 3 terms.
Even that 1 gets multiplied by 15. And theoretically, the 0 too, but the 0 is not going to change anything. I mean, 0 times anything is still going to be 0.
Do y'all understand why we're doing this? We're trying to get rid of those fractions because an ABC of fractions will be incredibly messy.
But by multiplying straight through by 15, am I canceling out every fraction? Let's see. 3 goes into 15 5 times. 5 times 1. Y'all see how we just went from a 1/3 x squared to just a 5x squared? I'm thinking I'd rather multiply through and have to do a little of that cross canceling than a equals 1/3 and b equals 1/15. There's no time you should ever have to be using fractions with the quadratic formula. Right here, 15's cross cancel.
So what's our b value going to be there? What
X.
number are we going to have in front of x?
Just a 1x.
1x?
You just write an x. I'm going to stick a 1 just because
We're going to need it in a minute.
A, B. Now C is no longer a -1. It's going to be a negative what? 15.
And what have we got on the right-hand side?
0.
Still stays a 0.
I just think that doing this little bit of multiplying here, I'd rather do that than A equals a third and B equals 1/5.
Realize we're using the smallest number possible. But there are other numbers. You need a number that 3 divides evenly into and 15. Well, 30. You could have used 30. You would have had a 10x squared. If you put a 30 here, 30 divided by 15, you would have had a 2. You would have had a 30 there and a 0. But, so there are other numbers. You just need a number that will divide evenly into all of those denominators. No, that the denominators divide evenly into.
Years and years ago, my brother was helping out his doctor's son with his algebra, and their teacher, they were solving equations like this, their teacher told them, do this. Take the first denominator, multiply straight through by.
Don't write this down.
Okay? But then it would cancel, and over here we'd have a 1x squared plus 3 goes into 15. Oh no, there's still a fraction.
No minus 3. 1 times 3.
Oh yeah, minus 3. Oh, gosh, messing up today. And now?
There's still a denominator. Multiply 3 by 5. That's just too much multiplying, I think. We can stop and think to ourselves. We're not going to have denominators like 246 and 38 and 570 where you're trying to figure out, oh, what number do those denominators divide evenly into? They're pretty painless denominators.
Yeah.
So you should be able to do it all in one sequence. But look, we did get the same thing. Gibby's method of
multiply through by the first denominator. Then if there's another denominator, multiply through by that. So he multiplied by 3 and multiplied by 5. Multiplying by 3 and 5, isn't that the same thing as multiplying by 15? Now do we have something that's pretty easy to work with the quadratic formula? I sure think so.
I'm doing another problem after this,
okay.
So
okay, let me do this quickly. Negative b plus minus the square root of b squared minus 4ac all over 2a. How many of y'all have already memorized the 2a? If you do enough of these, and starting in the next assignment, we always like to try to have 15 homework assignments or 15 problems per assignment. And so starting with the next assignment, we were only able to find 14 we wanted to assign. So number 15 will be a review, and it's another quadratic formula problem. So we'll have a lot of, as the semester progresses, you'll do a lot with that quadratic formula.
Just because it's going to keep popping up at the end of homework assignments.
Ooh, I didn't even ask y'all. I'm just getting ahead of myself. A is 5, B is 1, and C is negative 15. So let me start trying to plug into this quadratic formula. I have the plus, minus, and the square root. So let's see, what do we have? Negative b, would that just be a negative 1? Plus minus the square root, don't help me, I can do this in my head. B squared, 1 times 1 is 1. Minus 4 times A times C. A is 5. Ooh, and C is a negative 15.
Is that a 61?
All over what on the bottom? Y'all caught up?
What's the denominator going to be?
10.
2 times 5 is 10.
underneath that radical, we have a 1 plus 300. Look at that. We have a square root of 301.
All of that simplifies to just a 301. 20 times 15 is 300. It's minus a negative, so it's going to be plus. Yeah, I agree with your calculations. 1 plus 300 will give us 301. Oh, wow. It's 301. It's not a perfect square. But is there a perfect square that divides into it?
No. I think 301's a prime number.
Certainly not 25.
Look, show them your list.
49.
Tony.
Oh, yeah.
Show them your list. First of all, let me convince y'all that the square root of 301 is not
a perfect square.
Yeah, that's not an integer. 17 point something. No.
And you would use the terminology irrational number. That's a decimal number, a square root that's a decimal.
That just goes on forever. That's an example of an irrational number.
Because back in the olden days, when they discovered those numbers like that existed, they thought it was crazy, so they called them irrational. But they weren't using English. They were using Greek back then.
Write out the answer, Tony.
Oh, what's my answer going to be? If the square root of 301 can't be reduced, is it just negative 1 plus minus the square root of 301 all over 10?
I've told people, there's some teachers that don't like my lab because the teachers can't control the numbers. We have no control. We're working a problem. We're stuck with that square root of 301, okay? And what I've noticed through the years is if it's some weird number, square root of 301, odds favor. If it's some weird looking number, it can't be reduced any further. It's probably prime. And so even though they're generating these numbers algorithmically, they're putting some thought into making sure you're not having a square root of 248,324. Well, what divides evenly into that? If it's something that's a little unusual, odds favor that it can't be reduced any further. Watch us type in the answer and it be wrong.
Oh, I've already done it. I did.
Oh, okay.
Because you said you needed to, one more example?
Yes, I have one more example. And, oops. No, it's working now. If you turn it, I found if you turn off the microphone, is it working? Is it? Yes. I hope so. The battery's nearly dead, but if you turn it off and let it rest, it'll get, it'll do a little bit more. This is going to be something that pops up similar to this on Monday. Monday we're doing rational and radical equations, and we won't have time to spend a lot of time discussing how do we solve. So far, our coefficients have been very painless. They haven't been big numbers. You haven't had a C value of, say, 99. So here, okay. Let's solve this equation. Believe it or not, this equation is factorable. It's factorable. But whether you're going to solve it by factoring or the quadratic formula, you need one side equal to what number?
0.
0. How do you think I'm going to get the 0? Or where do you think I'm going to get the 0? Left side or right? The left side, because I don't like that negative 4 in front of that x squared. I want that a value to be
positive or negative?
Positive. Okay. So moving it over. And this problem popped up last semester during the square root equations that we're going to be doing the next time. And
the instructions didn't say solve using the quadratic formula. So it can be factored, but
Suppose you're trying to solve something, okay, you think it's factorable, but you just don't see the factorization. You can use the quadratic formula, and what I want to do is I want to illustrate how do you handle this quadratic formula when you have pretty large numbers. Well, A isn't bad. What's my A value? 4. What's my B value?
-47.
In a minute, we're going to have to square that. And so 47 times 47, we're going to pick up some pretty big numbers underneath that radical. What's C?
99.
Okay.
We have our calculator to help us out.
Yeah, and we'll write down our quadratic formula. And if you're trying to solve an equation by factoring and you're stuck, maybe you'll want to resort to the quadratic formula. Negative B, the opposite of B. What am I going to write right here?
47.
47. B squared. It's negative 47 times negative 47. Negative times negative. I can do that in my head. I know that's positive. But what's 47 times 47?
2209.
2209 minus 4 times A times C.
Look at how I'm going to get an answer. Well, go ahead and.
All over. What's 2 times A? That I can do in my head. You're right. 2 times A, 2 times 4 is 8. Let's work under that radical. Let's reduce that discriminant. You have 2209 minus 4 times 4 times 99. Oh, and by the way, let me do something else. I have some students that will say, oh, they don't have a parentheses key. Those parentheses just mean times. If you don't have parentheses key, you can just say 2209 minus
No. Oh, yeah.
4 times 4 times 99. You can just use the times in place of those parentheses. And look at what we're getting under the radical.
They might not recognize what you recognize.
Yes, they're not recognizing it. Am I going to have an I in my final answer? No. What about 625? Is that a perfect square? Yes, it is. 625 is 25 times 25. The square root of 625 is 25. This is the first time we've used the quadratic formula, and the thing under the radical, it's not imaginary. It's not going to be, we're not even going to have a radical remaining in our final answer. That's 47 plus or minus 25 all over 8. The square root of 625 reduces to 25. But you cannot stop there. People want to stop there. No, if you have a radical, you stop there. If you have a radical left over, does our top have a radical remaining? No, you have found 2 possible answers. You have 47 plus 25, and you have to break it up into 2 separate cases.
And that's what you're illustrating.
This
right
is what
now.
I'm illustrating. This is the important part of the problem. If you're solving an equation using the quadratic formula, that could be factored. If something where you don't have a square root, you're going to have to split it up. 47 plus 25, is that a 72 all over 8? Hey, this works out real nicely. What's 72 divided by 8? 9. Okay, so we found one of the solutions. Now we have to take into account the other situation. 47 minus 25 all over 8. 47 minus 25, is that a 22 over 8? And we can reduce 22 over 8. There's a common factor. What is it? 2, so 22 divided by 2 is 11. 8 divided by 2 is 4. If you're using the quadratic formula, and in the next assignment, some of the equations, this equation appeared in one of the problems last semester. We'd already been going through trying to eliminate square roots, and eventually we got to this point right here. And I saw the factorization quickly, and I factored it, but then when it became clear that people didn't see the factorization, then we went ahead and reworked it by factoring as well, because they never seen a situation where you have to then take the plus minus situation and split it into two separate cases to get two rational solutions. Any questions there?
And so it's important that they see if we're factoring something and you can't factor it, for some reason you don't see it, just use the quadratic formula.
But it's essential that you be able to factor. Once we get to those rational zeros, it's going to be important even once we get to
but if you have these huge numbers, we're not going to have those huge numbers.
We're not going to have those huge numbers like that. Right. Let's see, how would that have factored? It would have factored as an x minus 9 and a 4x minus 11.
36 and 11.
Here was the factorization that I saw very quickly in my head, and the rest of the class didn't, but I was trying to rush, so.
And you'll know why we're saying we're trying to rush on Monday.
Any questions here?
And
you really need to have worked on this assignment by Monday, because Monday we're doing rational and radical equations. Last year we had an extra day, and so we split it into two separate lessons. This time we don't have that extra day because we missed Wednesday of last week. Okay? 1 week ago today, we had the
snow day.
The snow day, we'll call it.
Yeah.
So now we have to go back the way we used to do it, where we would teach the whole assignment in one class. And
so today we're finished at 4:04. Probably on Monday it's going to be more like 4:30.
Maybe 4:40.
It's going to be a long one.
For the exams, do y'all have anything